I thought I would make a video to help you learn how to learn the polyatomic ions. There is some bit of a method to the madness. I wanted to try and unlock some of these hints for you to make it easier while you're memorizing them. Alright, so you'll notice that some of these ions don't seem like they follow a pattern, but they really do, and there's a nice way to remember all of these. Some of them you just have to know. So the first set on these +1 charges, hydronium, ammonium, and mercury 1, those are all the plus charge ions, and you just kind of have to know them. A lot of students mix up ammonium and hydronium, or hydronium and hydroxide, and hydronium starts from water, H2O, but it has an extra H on it. There's H3O, so there's extra proton. That's what makes it have the positive charge, so it comes from hydro, water, so maybe that's an easy way to remember it. Ammonium comes from ammonia, which is NH3, and there's an extra proton on it. You're going to notice that a lot of these ions just have an extra proton on it, and by proton I just mean an H+. Okay, so that's our proton. Mercury 1. Why is mercury 1 in the +1 category when it is actually a +2? Well, mercury 1, each mercury atom is +1, and when you have two of them together, it becomes +2. So Hg2 with a 2+ charge. So that's the +1 charges. Alright, so some other things to note. There's a few of these that you just have to know them. Carbonate doesn't, well, it does, maybe I'll come back to carbonate. Hold on. Silicate is kind of a singular one. It doesn't really come on any of the other lists. SiO3 with a 2- charge is silicate. Oxalate is another one with kind of a funny name. C2O4 with a 2- charge. That one kind of just have to know. Peroxide is another one that you just have to know it. Oxygen with a 2- charge. So O2, 2- charge is peroxide. So that's for the -2 charges, some of those that you just gotta see it and know it. On the -1 charge side, hydroxide is less a proton from water. So hydronium and hydroxide are kind of coming from water, where you're just either adding a proton or subtracting a proton. So you get the OH- charge because you lose the H+. Acetate, another one. Some people call it the 2,2 one, CHCOO. You can also write it C2H3O2 with a minus charge. Cyanide, again, Cn-. Thiocyanate, another one that doesn't really have a method to it. Permanganate is kind of interesting because it has this per and ate, which we're going to see in another series in a second, but we don't really talk about manganate ion or manganite. Those, I don't think they exist. MnO4, though, is permanganate. Per always goes with 8. Okay, so speaking of per and 8, I'm going to have us look down at this bottom part of the -1 charges, which made me see that azide is down here hiding. Azide is also one of those. You just got to memorize it. Alright, so this set, it looks like a long list, but it's actually only 4 things that you're looking at. You're going to notice that we have hypoite, ite, 8, per 8. Hypoite, ite, 8, per 8. And again, hypo and ite, 8, per iodate. Okay? So there's this repeating pattern. And all that's going on here is you're adding an oxygen. The charge is still -1. But you have ClO, ClO2, ClO3, ClO4. So when there's only one oxygen, you have the hypoite, and then whatever the ion is. Chlorine is chlor. You have ClO2, 2 oxygens is ite, 3 oxygens is 8, 4 oxygens goes with per and 8. So a little bit of a pattern, And then you just change chlorine to bromine and bromine to iodine. And by doing that, you end up with a whole new 4 set. Okay. So these ones, even though there's 12, really you just need to remember that it goes hypo with ite, and then there's ite, 8, and per, 8. So 4 things to remember, and that's it. Okay. Some of the other ones. These two, nitrite and nitrate. These ones kind of have the same ite 8 as our the halogen list here, chlorine, bromine, iodine. Nitrite is NO2 along with bromite, chlorite, iodite. They all have 2 oxygens. Nitrate has 3, kind of like chlorate, bromate, and iodate. We can use that on these ones, but you can't use it for every single one. Okay, so then it gets a little bit more complicated. The rest of the ions they have a different 8-ite ending with the number of oxygens. So I'm going to look specifically at these 2 first. So we have sulfite and sulfate. In this case, the ite goes with 3 oxygens, 8 goes with 4. The ite always is the less oxygens. 8 is always the greater oxygens. Okay, so that should make sense from here. Chlorite, hypochlorite and chlorite both have the smallest number of oxygens. Chlorate and perchlorate had the greater number of oxygens. So there's a little bit of method. Okay. Carbonate doesn't have an ite counterpart. Carbonate is the only one. You could add a proton and get hydrogen carbonate, which in that case, you are taking the 2 minus charge, you're adding a positive charge to it, so it becomes a 1 minus charge. Minus 2 plus 1 is minus 1. So a lot of the rest of the ions are actually 1 proton different from the next charge over. So I'll look at down at the bottom of this list. We have phosphite and phosphate. Ite is the less number of oxygens, 8 is the greater, so phosphite and phosphate, we've got PO3, 3 minus, PO4, 3 minus. The charge hasn't changed from phosphite and phosphate. They're the same charge, which is nice. If we add a proton to it and get HPO3, the 3 minus charge becomes 1 less positive, or 1 less negative. You're adding a positive charge. So if I'm going from the minus 3 category and adding a hydrogen, I'm going up to here. Hydrogen phosphite, hydrogen phosphate. Still have the O3 and O4. Ite goes with the less, 8 goes with the more. Arsenite and arsenate are the same subscripts of oxygens with the ites and the 8s, but in this case we won't have any up in the top in the minus 2 charges with a hydrogen on it. You could, but that would just make our list even longer. So we have these 2 match the phosphite-phosphate series in terms of charges and subscripts. Another one, moving on with this, hydrogen phosphite and hydrogen phosphate could add another proton. They have a 2 minus charge right now. If we add a proton, we get dihydrogen phosphite and dihydrogen phosphate. Still with the PO3, still with the PO4, just now there's 2 protons on each of these ions, and we call it dihydrogen. Okay. If I added another proton, I would have the acid, it would be called phosphoric and phosphorus acid. For carbonate, CO3 with a 2- charge, if I add a proton to it, I get hydrogen carbonate. So there's now, instead of being a 2- charge, it's a 1- charge. Carbonate goes to hydrogen carbonate. It's also got the name bicarbonate. If students learn the bicarbonate name instead of hydrogen carbonate, I'm okay with that. We can use them interchangeably, but its true name is hydrogen carbonate. If we take the sulfites and sulfates and add a proton to it, we get hydrogen sulfite and hydrogen sulfate. They also are called with this bisulfite, bisulfate name. So you can learn either name. But sulfite was SO3. Hydrogen sulfite is HSO3. The charge was 2- and it became a 1- when we added a proton. Same for sulfate. And lastly, I think the last two I haven't talked about are these ones right here. We have chromate and dichromate. Kind of annoying that dichromate isn't exactly twice a chromate, but CrO4 with a 2- charge, Cr2O7 with a 2- charge. Chromate, dichromate. There's 2 chromiums in this compound, or in this ion. A lot of students get oxalate mixed up with chromate, but oxalate has a carbon, chromate has the chromium ion. I hope this helps. My polyatomic ion sheet is now a mess, but I encourage you to keep on studying. I often have students writing these out because it trains their hand how to write these ions, and that I think is one of the most helpful ways of learning it, other than using flashcards. But good luck on your polyatomic ion quiz.